Hello everyone. So today I'm putting together a control solution for the experiments that I'll be doing, and I decided today would be a good time to kind of talk to you about how to control for variables. And you learn in school that when you do an experiment, you have one group which you do something to, and then you have another group that you don't do anything to. Although it's true, it's not often that simple. And here's what I'd like to talk about. So for the experiments I'll be doing, I'll be adding two hormones separately, not together. One group's going to have this hormone, one's going to have the other hormone. This is indole acetic acid, and this is naphthalene acetic acid. I will be adding those to the algae and then seeing how they respond. Thing is, these aren't water soluble or anything. There's actually a process where you have to use sodium hydroxide to dissolve it, and it's a process. And there's vials in here, and I have them in here because they deteriorate with light, but there's vials in here with each of the hormones, and it comes out to about half a gram per 50 milliliter of solution. Now you might say, well, that's easy. You have one group that has the indole solution, you have one group that has the naphthalene solution, and then you don't add anything to the other group, right? But that's not really how it works, because I'm not testing the effects of the naphthalene acetic acid solution on the algae. I'm testing out the naphthalene acetic acid effect on the algae. And there's a difference, because in these vials, if you have, I'm not going to take it out, but in the vial, you have sodium hydroxide and some culture salts that the algae grow in, right? So, and what I'm going to do is I'm actually going to mix up this solution. So, because the solution isn't just the hormone, I have to essentially simulate everything that's going to go into the experiment minus the hormone. I'm going to essentially make the same exact solution minus the hormone, which is 5 milliliters of sodium hydroxide and 45 milliliters of the culture salts. It's pretty much, it simulates salt water, and it creates carbon for the algae. So it's always important to isolate the variable you will be using. And you're only testing for one specific chemical in there. You have to recreate the solution the best you can, minus whatever your test compound is. Now, what I put in there was the culture salts, and now I'm going to put some sodium hydroxide. 5 milliliters. Then I'm going to top that up, and I'm going to mix it around. For this control solution, it's a hormone control solution. It doesn't mean that it controls the hormones. It's essentially, this is my control solution, and it essentially mimics the solutions that are in this bottle minus the hormones. And the reason for this is, let's say, for example, the sodium hydroxide has some kind of effect on the algae. If that's the case, and I don't add this solution to the test, there might be a change to the hormone group that has nothing to do with the hormones themselves. So it's always very important to get a full list of all the compounds that you're using and simulate that minus whatever compound you're trying to control for. And this is the case with any sort of chemistry, biology sort of experiments that you might be conducting. It's always important to get that control dialed down. That way you don't get any erroneous results because of other contamination that you didn't think to control for. Thanks for watching this video, actually, and I'll catch you at the next one. Make sure to like and subscribe.